Hi everyone, welcome back to Raw Talk Podcast COVID Decoded series. I'm Grace, and today I'll be hosting our 8th and final installment, discussing COVID-19 immunity in Canada. Before we begin, we wish to acknowledge this land on which the University of Toronto operates. For thousands of years, it has been the traditional land of the Huron-Wendat, the Seneca, and most recently, the Mississaugas of the Credit River. Today, this meeting place is still the home to many Indigenous people from across Turtle Island, and we are grateful to have the opportunity to work on this land. If you're new to Raw Talk Podcast, we are a graduate student-run show about medical science and the people who make it happen. You can check out the description for more information about our show, and you can subscribe and tune in on all of your favorite podcast apps. I'd also like to take this opportunity to thank our incredibly hardworking team behind the series, including Alex, Kat, Richie, Thamia, Yagnesh, Jesse, and Mel. We would not be able to pull this off without each and every one of you. I'm very excited to be joined by our guest for our discussion today, Dr. David Naylor. Dr. Naylor is a professor of medicine and president emeritus at the University of Toronto, a fellow of the Royal Society of Canada and the Canadian Academy of Health Sciences, an international member of the U.S. Academy of Medicine, and an officer of the Order of Canada. He is the co-author of approximately 300 scholarly publications, spanning epidemiology and public policy, as well as clinical and health services research in most fields of medicine. Dr. Naylor chaired Canada's review of public health after the 2003 SARS outbreak, and is currently co-chairing the Canadian COVID-19 Immunity Task Force. One last note before we begin, I want to quickly remind everyone to send your questions to the live YouTube chat box. We'll be reserving the last 15 minutes today for all of your questions. Okay, now without further ado, let's welcome our guest, Dr. David Naylor. Thank you for being here.
Thanks, Grace. Very pleased to be here again.
So first of all, I'd like to ask, what is the Canadian COVID Immunity Task Force, and why was it formed?
The task force was formed in late April of this year as part of the federal government's response to the epidemic in Canada. And I think the motivation at the time was a sense that there might be a lot to be learned from serology. That was kind of the initial thinking. By serology, I mean specifically the measurement of antibodies to SARS-CoV-2. And at the time, you may recall, it's a compressed period where days feel like weeks and months feel like years. At the time, it felt as though there might be sufficient undetected cases because of the sense that there were a lot of asymptomatic and mildly asymptomatic individuals with this infection, that the background immunity might be much higher than we were suspecting. There had been some discussion in other jurisdictions about which a lot of us were skeptical regarding this idea of immunity passports, that you would somehow, if you had antibodies present, you would have an inference that you were immune and that you could travel safely because you did not have any risk of contracting and, more importantly, passing along COVID-19. And even some concept that perhaps people who were immune could take on frontline healthcare jobs more easily or be in public-facing positions. Pretty far-fetched, frankly, but certainly something that needed to be thought about in the context of some of the discussions at the time. So the task force was set up, at first with a strong sense that we should be looking at seroprevalence, but also we were at some pains early on to make sure that we had a meaningful amount of work slated to be done on the immunity of the disease, translational immunity studies. So we're very fortunate in that respect to have Charu Kaushik on the leadership group of the Immunity Task Force. Professor Kaushik is not only head of the Institute of Infection and Immunity at CIHR, but a professor at McMaster with a great record of research in her own right. And so she would give us a window. Gary Covinger, another renowned immunologist, was on the task force, very involved with the Ebola vaccine work. So, some serious thinkers on immunity who would help us to navigate an interface where we thought CIHR would be a partner, and then we've already done that very happily with our colleagues at CIHR. So two arms really, one focused on testing seroprevalence, which would involve field studies as well as attention to the technology of testing, and then of course an immunity sciences group that would be working along to try to get a handle on this incredible moving front of basic and translational immunity about COVID-19. So those were the rationales for creating the task force. We've been at it for, I guess, 3.5 months. And it's been a very interesting ride.
And before we go any further, I was wondering if you could define immunity and how we're measuring it with COVID-19.
Yeah, that's a surprisingly challenging question, especially for a clinical epidemiologist transplanted into infectious disease and immunology. But I think the general public tends to think of immunity as protection against disease. It's a sort of get out of jail free card. And in fact, technically immunity is simply a host response to an antigen or a pathogen. And, doesn't necessarily mean that you've got neutralizing antibodies or that you have T cells primed to respond to a pathogen. It simply says there's a response. And in that sense, important to remember, we start life with innate immunity, which is a sort of broad blueprint, a bit rough and ready for responding to anything that isn't us. That innate immunity is kind of the starting point. And then we tend to take that for granted. But then, of course, throughout our life course, whether naturally or through vaccinations, we acquire immunity. The acquired immune system is really the one that comes into play, obviously, with a pathogen, a new pathogen, like this novel beta coronavirus. So, it's the thing that is most striking for me as something of a layperson transplanted into this world is the phenomenal complexity of sorting out the immune response to a novel pathogen or any pathogen. And, I would say my one takeaway from this is not just that we really need to keep our A game intact for responding to zoonoses, to new pathogens, because I think we slid a little bit after the initial important responses to the SARS outbreak, and we raised it a bit with the flu pandemics that we've had, but never really sustained everything at the level that we might have required to deal with this particular big one, the once in a century type of outbreak. But more importantly, from the standpoint of the background work being done here, we need to invest in virology. We need to keep investing in immunology. We need to keep the science substrate going. And I do worry that we get focused on virology after every fresh outbreak or epidemic of any proportion, just as we get focused on public health for a year or two. And then this kind of thinking goes into abeyance. There will be more zoonoses. There will be more outbreaks. They may come faster with global warming and the crowding of the planet. And I think we need to be on alert for more of the same in the years ahead. And that's simply an imperative in terms of the science and the public health investments that need to be made in the future.
Coming back to kind of the creation of the task force, just wondering, is this a common occurrence for diseases, or is it kind of a unique thing that's happened for COVID?
I think it's uncommon. I mean, there are standing groups that will look into a particular condition. We've had national organizations like the Canadian Partnership Against Cancer that have been created. We've had a mental health agency with a national focus as well. So these are not unknown for broad disease categories. It's unusual to have them focused on a single pathogen, as is the case here. So I think this is a bit of an unusual moment and an unusual occurrence. On the other hand, there's right now 3 federal task forces, and there may be more, I'm only aware of 3. One looking at therapeutics, one looking at vaccines, and ours looking more generally at immunity with a particular focus on some of the seroprevalence and trying to get a sense of where we are in the course of the epidemic. So all 3 of them need to talk to each other. We've had a great meeting in the last couple of days with the vaccine task force. Co-chair Kate Hankins and I spent about 45 minutes with them. Very illuminating conversation, but we need that crosswalk to occur. My sense, Grace, is that these mandates are converging pretty fast. We're working quickly towards a vaccine. If you're going to go vaccinate as many Canadians as possible, then you're not going to be looking for background immunity anymore. You're looking to see how the vaccine is working. And similarly, the Therapeutics Task Force is obviously going to be looking at things like monoclonal antibodies, novel things like nanobodies, fragments of engineered fragments of antibodies that could neutralize the virus. So as they begin to use immune elements in their toolkit, there will again be a crossover. So a three-way conversation will be necessary and some convergence in the next few weeks.
Would you mind telling us a bit about the recent seroprevalence study findings and maybe expand a bit more on what is a seroprevalence study?
Glad to do it. So seroprevalence studies are a kind of well-established part of infectious disease control. And what you're looking for is evidence of infection based on an antibody response. And the rationale is that not all disease is going to be detected by diagnostic tests, or the diagnostic tests may not be that efficient or effective. And on occasion, it is more efficient and effective to measure the antibodies that arise in response to that particular pathogen. So seroprevalence studies are launched to track the course of an epidemic, track the course of a disease. They're done serially. And the other thing that's done is early on to do some cross-sectional work to just get a sense of how far the outbreak has spread as you're taking first sounding, getting a baseline. Commonly in seroprevalence studies, to get things done quickly, you will use things like leftover blood. So routine lab tests are done, the serum is available, and the serum can be analyzed from some cross-section of the population, not a perfect random sample, to get an idea of who has been infected. And then later on, you may get to more purpose of random sampling, or you may actually focus on hotspots where there's a particular concern about vulnerability, or to understand how a particular outbreak may have affected a population. So these are some of the common uses in public health. Also can be useful for investigating an outbreak to try to get a sense of just how far it spread and what the time course is. That involves some quantitation of antibody titers, but can also be done. So a number of uses of seroprevalence studies, mostly focused on public health guidance and less so on actual clinical applications, although there are some.
And thus far with COVID-19, there have been at least a couple of seroprevalence studies that have been released. If you tell us a bit more about the findings from those.
Sure. There have been several studies that have been released. I think about 23,000 people have been tested so far, but that have been reported. Many more than that have been tested, and we're still compiling data on them. The task force has worked with a number of the groups, Canadian Blood Services on a 9-province study, supported on Public Health Ontario on their study, supported Alberta Health on theirs as well. So if we look at BC, Alberta, Ontario, Quebec as well, those 4 provincial specific studies, and then the national study, you get a pretty consistent picture. One way to think of it is that you're looking for the missed cases. So just the math gets pretty simple. Let's say we've had 120,000 confirmed cases, usually with full nucleic acid amplification tests, PCR tests. And that's our current count. So 120,000 over 37, 38 million Canadians gives you a pretty good picture there. It's about 0.3%. On the other hand, the prevalence of antibodies is running from a low of well under 1 to a high of somewhere over 2, with an average from all those various studies somewhere north of 1%. And you think of that, you can say, well, we've got at least 3 cases that are likely to be undetected. For every case we've detected, obviously some of those people may have had infection and been labeled as such, but just on balance of probability, most of them will not be in that cohort of infected people. So think of it as a ratio rather than including all those people. So 3 to 1 at minimum. I wouldn't be just surprised to see that number rise a little bit as we get a full national sample and also over time. It may be depressed a bit by waning of antibody titers because a lot of the sampling has been done after the peak of the epidemic. But we know there is an iceberg here of undetected cases, but I would just say the good news is it's a lot smaller than we thought it would be, which means that we've been pretty efficient at testing. The bad news is it signals that there's substantial susceptibility across Canada, and not a lot of people who have any prospect of being protected against the organism. Last thing to say is that also suggests community spread has been less than we were fearing. And this speaks to another issue, which is we have had an outbreak where there was a tragic concentration in seniors' homes, in long-term care facilities, and a disproportionate number of elderly infected and disproportionate number who have died. And so one thing that maybe has happened in Canada is that the total toll in terms of deaths and infections is skewed by that very unfortunate, I think tragic, failure to protect those facilities, and that the community spread actually is less than meets the eye. So all of that says Canadians have done their job. They've been meticulous about following all the various orders from public health agencies, and community spread has been moderate.
That's nice to hear.
Yeah, we're very obedient. Peace, order, good government. The thing.
In this case, that's fantastic.
Yeah.
I was wondering, how accurate are the antibody tests for COVID-19, and if there's any kind of limitations there, or kind of a little bit more broadly, if there are some limitations to these studies, and what the plan is to address those going forward?
Yeah, lots of limitations. Great question. First, the threshold that the government has set is sort of trying to get these to 95% sensitivity and your sort of true positive rate, and trying to get it to 98% specificity to minimize the false positives. The challenge with this is that when there's low prevalence, you amplify the problems with false positives. Just simple math. If you've got 98% specificity and very low prevalence, let's say 1% prevalence, then though it's rounding here, you'd say, okay, we've got 2 false positives for every 1 true positive we're going to pick up, roughly speaking. And that's a nuisance of sorts, and has to be taken into account in interpreting the numbers. The challenge in part is that when you use samples like blood donors, you also have a discounting effect because these are healthy volunteers, often public-spirited, a little health conscious. So we know from worldwide studies that there's about a 50% inflation factor that you need to apply to blood donor studies. Leftover sera studies are harder to pin down because they have a wider angle of intake. In fact, may involve more people who are elderly and relatively frail in terms of comorbidity, or else the test might not be done that have yielded the leftover sera. However, this is a blend of leftover sera and blood donor studies. We're thin on children, although the task force is busy working through a consortium to look at serology in children. That's unfolding pretty much as we're talking, that work. And we're hoping to get a number of provinces into that consortium. That's a very active front right now. At some point, we're also very keen to get at a number of other populations. We have a partnership already launched with a group of investigators grounded in the Indigenous community, and that study will be an important study. It will sample a large number of rural and remote communities that are predominantly Indigenous, and I think will be an important source of insights. We'll see, just whether those communities have been protected in the main. We know there have been outbreaks, but most of the communities have smartly, I think, kind of pulled up the drawbridge and said, let's just be careful about who comes in and out. So we're hopeful that most of them will be very limited seroprevalence. And we're also hopeful that continues to be the case, because these are vulnerable populations. Also looking at the Canadian Longitudinal Study on Aging to support them to get a sample of at least 10,000 seniors, and other partnerships that are still not pinned down, which we'll announce in the days and weeks ahead, that involve sampling to pick up other groups. We're certainly interested in the homeless. We're also interested in trying to understand differences between seniors facilities that have had an outbreak versus those that have not. A long list of areas that are on the agenda, including hotspots in some of the neighborhoods in our big cities. So these are all gestating or in negotiation. Bottom line, we can measure a lot of communities. We can try to get really specific. We can try to do a much broader national study, which is actually in discussion as well. A really big national random sample is certainly on our radar. But at the end of the day, if these are all 0.5 to 2.5%, the information value for managing the epidemic is pretty thin. There's one big signal coming out of that, not much noise. The signal is, be careful in the fall, let's get vaccinated, and let's be smart about the next few months.
For the antibodies, what do we know so far about, even if we find antibodies in somebody's system, how long those last, and what that really tells us about whether or not that person can get infected again?
Yeah, that's a fabulous question, and I think the literature has been really interesting on multiple fronts. First, as everyone knows, the preprint servers have gone crazy. And what's impressive is the signal to noise ratio has really been pretty good. A lot of those preprints that get attention end up in decent journals. There's not much dross. And if you track this, I think we've migrated from an initial sort of, I'd call it a fantasy almost, that these antibodies will be durable, they'll all be important in terms of protection. This is the immunity passport fantasy, which, red, green, yellow type of traffic light results, which really was always naive, I think. We are seeing that antibody titers wane, and some of the early reads have been they wane within a matter of 3 months or so. Some have found they wane perhaps even faster, but certainly it's a matter of months, not years, that we're seeing titers begin to decline in a substantial number of people. And as I look at this in comparative perspective, having been through SARS and having tracked that work for a couple of years after the federal panel, it looks to me as though this is a little faster than with SARS or Middle Eastern respiratory syndrome. The other thing that's being noted is the neutralizing antibodies, which are the important ones here in terms of their effectiveness in impeding the action of the virus, based on either pseudo-neutralization assays or assays using live virus, so-called plaque reduction assays. Those antibodies that are the most important in a sense also do attenuate. And then, of course, the question becomes, does it matter? And the answer is, we know with SARS and MERS, SARS-1, that studies done in follow-up showed that, and I'll use shorthand here, the broader terms, T memory cells had evidence of SARS and MERS-specific immunity baked into them for years, going out many years, not just a couple. We're talking 9 years, 11 years, really substantial evidence of immunity. So I think we probably will find if we get to the analyses, B memory cells may also be there. So I think there is reason to be concerned about waning antibody titers from the standpoint of measurement. I mean, it's tougher to track the course of the epidemic, and that we can't just accumulate these counts. On the other hand, from the standpoint of whether it means that people are not immune in the lay sense, protected, it may not be as meaningful as one might fear at first thought.
What do we know right now about whether or not the virus is mutating, and kind of what that means moving forward when when we get a vaccine, hopefully, in terms of will we need to get that vaccine every year, or will kind of that vaccine provide protection for a longer period of time, like, yeah, a different type of vaccine?
Okay, so I'm going from being a fake immunologist to being a fake virologist now. This is really an adventure into imposter syndrome. When I think about the virus and what we've seen of its genome, it's, aside from the fact that this thing was sequenced pretty early in January, which is stunning. It's so different than the struggle to sequence SARS-CoV-1, the race really. I'm sort of struck by a few things. One is that while there have been a fair number of mutations, it doesn't look as though any of them have been dispositive in terms of really greatly accentuating or attenuating the infectivity or virulence of the organism. And if anything, I would say the mutation rate has been slower than you might expect with a pretty simple RNA virus. RNA viruses like to mutate. So I've been cautiously optimistic about what we're seeing in the last few weeks. With SARS-1, it was quite interesting that there was a mutation in 03 where one of the strains actually was less aggressive, less infective. And the hope always is with these mutable viruses that the mutation goes in a positive direction, that these things set themselves up to burn out. But obviously with this one, given how it's behaved, very high baseline exponent of infectivity. Not as high as measles, not even close, but sitting in the 2 to 3 range. The fear was that you might have some further mutations that would make it even more dangerous. And so far, I don't think we've seen that. People are still sorting out whether some of the differences actually are relevant. Lots of great genomics going on, yet to see something that really puts my red lights on.
And coming back to why this information is so important to collect, how is the government or public health responding to data coming out of these studies?
It's been very interesting because there's been a real focus on trying to track these data. A whole bunch of players involved. The Chief Science Advisor, Mona Nimmer, who's also on our task force, and I think cross-appointed to all these task forces, has been trying to make sure that there is a group not only tracking studies, but trying to assess where the literature is going worldwide. A number of groups, including one at the Delaware School of Public Health, are trying to do systematic reviews to get a sense of where the literature is moving. So I think people are using those resources in academia as never before to assimilate the literature and see where it's going. There's also, as these task forces indicate, a real effort to assemble and rely on individuals who have some scar tissue or some expertise. I put myself in the former category, not the latter category. But that means that the ability to contact senior people in government and get concerns across to them has been really striking. Really from February onwards, I've been really encouraged by how easy it is to get in touch with senior people in the federal government, and they're listening and they're watching the literature. Provinces vary in how they've responded, but the provinces, to their credit, are working really well with the federal government and vice versa. So it's a rare moment in Canada when you see this degree of federal-provincial cooperation. The federation that puts the fun in dysfunctional is now looking pretty functional.
Yeah, it's definitely very noticeable.
Yeah.
And in terms of kind of current decisions being made, especially for the fall, schools reopening, or thinking about that, is that going to kind of change any of these decisions, knowing that immunity or any kind of response, immunity in the broadest sense of the word, presence of antibodies is fairly low in the Canadian population?
I don't think it will change anything. We're waiting to see if there's a breakdown coming out of Alberta. That will be important. They did a leftover sera study of several thousand people. They've given only the top line results. CBS, the Canadian Blood Service, would exclude people under 17, and so would Hema-Quebec, I believe. But we'll see as well if we can get some of these studies rolling faster, what some of the seroprevalence in children is. Based on the Ontario study, which had a small number of people 0 to 18, it looks much the same as the rest of the population, lower as you would expect, and obviously wide confidence intervals on that proportion, but pretty suggestive of what you would think. So I don't think these studies are going to change everyone's view, which is to go into the fall with a certain degree of anxiety about the reopening of workplaces and the reopening of schools. The schools are a conundrum of sorts because there is this ongoing debate about how infective children and teenagers are. And to me, it's sort of a precautionary principle situation where you want to space these students out, where you go to online learning. If you can't space out, you just basically go 50-50 if you have to. But I wouldn't want to see more than 15 children or teenagers in a classroom. I'd like to see them spaced out to a reasonable degree. We want to have protection for the teachers and staff. It'd be great to have public health nurses helping out with regular counseling. And at some point here, aside from masking as many of these kids as possible, it would be fantastic if we could get a fast, reasonably reliable diagnostic test. And everyone's running to get this done. I saw a report out of Israel today about a swish and spit test. I think it's an antigen test, like a lot of these kits, because it's baked inside of a few seconds. They say that by tuning the response to the spectroscopy with machine learning, they can get very high accuracy, very high true positive rate. I'll believe it when I see all the validation studies. The antigen kits have not been great so far. Paper strips are in the same category. There's just a boatload of people trying to figure out how to do nucleic acid tests that are more meaningful on a fast basis and reasonably affordable basis. We get those, it's a complete game changer. Then you would say in schools, let's do regular testing. Then in work sites, you'd say the same thing. To some extent, you can live with a little bit of degraded performance because you repeat the tests. And if there's a test that is a false negative, you repeat the test as the viral load rises, you get a positive. That's the kind of thing you look for if you're testing very regularly. There is a problem with false positives that could emerge, but you have an answer to that. Maybe you start with the screening test that's most sensitive. If you get a positive, you do another screening test that has a much higher specificity to clean up some of the false positives. If it's still positive, you send that kit along or that sample along to a public health lab for confirmation using a full PCR type test with nucleic acid amplification. And then you get a definitive result. And meanwhile, especially if it's a student, so they're home for a couple of days in isolation. It's anxious for the family, tough on the student, but you are able to protect everyone and provide online learning for that young person. That's where we could end up, which seems to me a nice place to be, and makes all this a lot more transparent and manageable for everybody and takes the anxiety level down, even though those false positives are going to alarm some people. It is time limited, and they can be clarified within 3 days. So that's what I've got my fingers crossed, hoping we get to that, because it'll make the fall in the next few months so much easier until we get a number of vaccines that work.
Kind of speaking of vaccines, can the information from seroprevalence studies tell us anything important about creating vaccines, or just in general, what is the overlap between vaccine development and testing for immunity?
Yeah, so I think we had thought that there might be areas of high enough background immunity that it might toggle where you focus your vaccine efforts. Given the numbers we're seeing, I think the answer is the priority setting in vaccination and planning is going to have to be determined by some assessment of what makes sense in terms of who's at risk, number of life years at risk, and comorbidity and its impact on outcomes. So there's going to be some very important questions to be asked. The ethicists will help us here about whether you focus on seniors because of vulnerability, do you focus on children because of life years, do you say because children generally do not have the same severity of disease and very few of them die, do you think of that differently and handle it differently? So a lot of questions that will need to be answered, as has been the case with other vaccines, by the way, by some kind of priority setting process, but it will not depend critically on background seroprevalence, I'm afraid. As to the other crossover, it's actually quite important, which is why the task force is probably going to converge in some way. When you do these big vaccine trials, you're going to be looking for three things. You're going to be looking for the relevant antibody response in all subjects. You're going to be looking for evidence to the presence of neutralizing antibodies, because they're the ones that matter most. And you're going to be looking for markers of cell-mediated immunity, because you would like the vaccine to be effective in baking in that response for obvious reasons. So there's three sort of types of testing that are done pretty routinely in these vaccine trials. When you get to the phase 3 trials, which are 30,000 subjects, and a couple of them are already underway, then a lot of this depends on what the regulators want. Safety is a huge issue in those studies, so they're going to be focused on safety outcomes. But another big issue that they will all be focused on for sure is, does anyone get reinfected in either arm, and assume that, or infected in either arm, these are unexposed people. So if someone is infected in the treatment arm, that's a big issue, suggests incomplete efficacy. So I expect they will use a blend of immunity tests, which are proxies for protection. But the real reason for having 30,000 people is to get beyond the proxies that suggest immunity in the lay sense for protection, and to look past the correlates of protection and look at actual outcomes. Did we have a whole bunch of people infected in the placebo vaccine arm, and ideally none infected in the active vaccination arm? Those outcomes are why you do the phase 3s. Phase 2s, a lot of immunity proxies are used to get a window on protection.
And kind of to one kind of final question before we move on to audience questions is, how does the task force's work now kind of inform our preparedness for possible future pandemics?
I think that we will be able to come out of this period of thinking with a much better blueprint about how we're going to go about using things like seroprevalence to track epidemics. In a better universe, you would have had, an instant mobilization of a series of antibody tests. You would have a plan for validating the various commercial kits. You might have had a very clear plan to use your researchers, some of whom have been doing unbelievable work with antibody assays, mobilize them to look at neutralization assays, or maybe to be an alternative to the commercial kits, which are not cheap. And you could have had a Made in Canada solution to say, we will do our own assays. Intriguingly, in Quebec, they are doing that. They're using a Made in Quebec assay. So not the easiest thing to scale, but these are all things for us to consider for the next one, and there will be a next one, so that we're better able to respond. We really need a scalable way to assess cell-mediated immunity. The ELISpot and other tests that are functional are a bit of a challenge to mount at scale, and some interpretability issues. So it would be nice to have a more quantitative, scalable assay. I gather work is proceeding in all kinds of places on that front, as you would expect, and that would be another useful thing to have. Right now, those assays are done by experts in many labs, but they're not things you just churn out with like throwing them into an automated machine and doing hundreds of them in a day, as happens with the antibody tests. So that's another area where I hope everyone does the research worldwide to make sure we can look at immunity in a more holistic way. So those are things I think will happen out of this task force and out of the experience generally worldwide, nothing specific to us.
What have been some logistical challenges as part of the task force to kind of mobilize these seroprevalence studies?
Substantial, I would say. The somewhat surprising. A classic would be the Canadian Blood Service. They did not have the machines that were required to do this work, and we had to make a calculated decision as to whether we would outsource that testing, which might have been faster, or to work with them, because it's a remarkable agency with a great history in terms of testing. Obviously, the terrible tainted blood scandals of yesteryear have hit home, and they really do an outstanding job now. And so the question really for us was, knowing that they have great laboratory capacity, should we work with Health Canada and get the testing machinery in their hands so they could track the epidemic along? And we said, this is a credible national agency, let's get the machines in their hands. But that slows you down. You have to wait for the machines to get delivered, installed, tuned up, and for them to be comfortable running the tests. On the other hand, now, our one of our two major blood agencies, Hema-Quebec being the other, is set to keep looking on a regular basis using blood donor material at the antibody prevalence, and they can just keep tracking and inform decision-making for the country on an ongoing basis. So that was whenever you do the trade-off between getting faster results versus getting something consistent. So there are these logistical issues all the way along. Another big one, Grace, is on testing substrate. It would be so great if one of these salivary things worked out and you could do not only DNA tests for infection, but test antibodies with saliva. Still not looking completely definitive on either front. But then if you're looking at remote communities, a classic is to use dried blood spots. And you can actually, analyze the dried blood spots, which are much easier to transport. Just a little finger prick. Or you can use a capillary technique as well and transport those tubes. Lots of different ways to move the substrate around. So we are now working closely with partners, and the National Microbiology Lab has been a really important partner, as well as all the public health labs, a large number of them, to validate things like dried blood spots and figure out whether they work well enough. Literature is mixed, some enthusiasm, lots of reason to think it should work. And if we can just pin that down, it'll make things a lot easier. For example, our Indigenous Advisory Circle would be able to, as it leads that study that I talked about earlier, use DBS rather than trying to do blood draws, which would make more sense. In many communities, it would be an easier way to get this done. For a big national random study, dried blood spots would be very efficient. So logistical challenges that in a better universe, back to your last question, we wouldn't be thinking this through right now. We would have decided all this and have the machinery set and know these things. I guess for a new virus, this is a novel virus, you'd still have to validate the test, but you would have a plan. You'd say, okay, here comes another one, cookie cutter, here we go, here's how we validate it, here's how we decide which substrates are effective. So I'm hoping both the collaboration and the commitment to be ready is something that endures out of this one. But as I said, the new normal is often a fantasy. The old normal isn't the best, but boy, is the inertia strong and people just go right back to where they were. Public health, not so important. Virology, oh, that's interesting, but no, we've got vaccines for everything we need. So I just hope that doesn't happen.
Hopefully not, for sure. I just want to ask a couple of audience questions now. The first one's about funding. How can we encourage governments and funding bodies to keep prioritizing research?
Virology.
Yes, after waves like SARS-CoV-2 have died down, which actually stems perfectly from what you just mentioned.
Yeah, I think we're going to have to do something that create some, I don't know whether it's a national network of excellence, network of virology centers, but we need to create some ongoing funding apparatus to make sure that we don't lose the plot again. And, as I said right off the top, it's HIV, was left aside to some extent based on, I think, discriminatory impulses and lackadaisical attitudes among those who are not directly affected. And then we had a huge push on HIV. Once treatment started, and it was less in the news, not to say the investment died away, but the emphasis abated. And same thing with SARS-1. Obviously, the virus pretty much receded from any kind of view. But you might reasonably have thought, well, we should be alert to coronaviruses. But then we had Middle Eastern respiratory syndrome a few years later, and it had a very high mortality rate. If you think of the mortality rates, this one is lower than SARS-1 is lower than MERS. So it's simply the infectivity and the spread of this epidemic that's made it led to this tremendous toll. So given that coronavirus zoonosis was an outbreak in 2003, you would have thought we would be on coronaviruses in a big way. Turns out there's not that many people even studying coronaviruses. So we do have this memory problem, this selective memory problem when life goes back to normal. And I think we probably have to bake something in to protect against that.
Mm-hmm. Our next question is about kind of population health. And given the results of the antibody studies, how far are we from successfully achieving herd immunity? And maybe what does herd immunity mean?
So herd immunity is some estimated level at which the number of people who have been infected and actually have protection to a meaningful extent against reinfection with the virus, or the number of people who have had protection induced by exposing them to immunogenic material, antigens that mean that they are protected by vaccination, where that number combined reaches a level that is sufficient to effectively halt the spread of the virus. And for a virus, with this exponent of infectivity, that level can be estimated at sort of 50 to 70%. I think a lot of people are wondering if that's actually what we need and whether that is too high. And we have this unbelievable group of people in Canada in multiple sites who are brilliant at mathematical epidemiology and infectious disease modeling. Be very interested in where they've come down on this question. Because the odd thing about the data that have emerged is that as you look at it more and more, what I call in my sort of perhaps clumsy way, the lumpiness of the epidemic is pretty evident. As I said, we've had this terrible concentration in seniors facilities, but the community spread has actually been pretty moderate. And then in other places, you see the community spread is unusual in that relatively small numbers of individuals seem to cause outbreaks or clusters in the Argot in special settings, an airplane where there were a whole bunch of people infected by a single individual. The funeral in Newfoundland, where almost 200 people were eventually infected by the spread from one funeral. The choir in Washington State, where the scores of individuals were infected from a single person at a choir practice. And some of this leads one to think that there are individuals who are, as we saw with SARS-1, spreaders. They may well be doing this by the amount of infected fine droplets they spread. And this comes back to this, what I think, false dichotomy between airborne and droplet spread. That's too simple. There's aerosolized material that we all produce as we speak, particularly if we speak loudly or sing or laugh, shout. And those droplets can be quite tiny. They're not like measles where they're desiccated droplet nuclei in all cases. But they're small droplets that can float for a while, and they are infected for some period of time. So if you think of this as a lumpy epidemic where there's a lot of clusters and it's simply not about community spread, then it may be that we actually can contain it with a lower degree of background immunity, and that we'll see real attenuation of spread as we climb up towards 50%. And that would be my bet, that this turns out to be intermittent clusters as we build the background immunity, and that this becomes more manageable quite quickly. That's my optimistic view. Last thing I'll say, and I'm going on at length, but this is an interesting one, at least to me. The T cell issue is really fascinating, because from multiple studies we've seen 20 to 50% of people have some T cell immunity to SARS-CoV-2, even if they haven't been exposed, through some cross reaction with what we assume are the more conventional coronaviruses. We have no idea how protective that is. None. But it certainly suggests that we may have some additional protection that we don't know about, and that there may in fact be quite variable susceptibility. Again, if you assume that not everyone's equally susceptible, and that not just by infection but by other coronaviruses there's some protection, this again changes the equation on herd immunity. So that's a too long answer, but that's how I see it.
Oh, definitely all very interesting. And I think perhaps, as you mentioned, not very many people were even studying coronaviruses before this, but they're actually fairly prevalent. And I think a third of viruses that are responsible for the common cold are coronavirus, which is exactly, as you were just saying, where some of that potential T-cell immunity comes from.
Yeah, they've all got spikes in some homology in terms of structure. The genomics are quite different, but with SARS-CoV-1 and CoV-2 being the most similar. But you can sort of imagine, if you're an optimist, that the similarity in terms of that structural biology. You're talking about structural biology in from the standpoint of how the virus actually interacts with the ACE2 receptor, might mean that there is some cross-reaction and cross-protection.
Mm-hmm. There's another question here about COVID and infectivity. And to get a better understanding of how infectious this virus is, do we know how its baseline exponent of infectivity compares with other well-known viruses? So kind of touched on that a bit, but.
Yeah, so the baseline exponent is between 2 and 3. The estimate I see most commonly is 2.6, somewhere mid-2s. Measles is up there in double digits. So that is higher than SARS-1, where we really had mostly super spreader events. It is certainly higher than MERS, but as compared to a lot of childhood diseases, this is lower, and particularly measles, which is sort of the paradigm for the airborne droplet nuclei as a spreading entity, where you walk into a room where someone had measles and they'd been in there chatting away hours before, and you can still pick up the bug. So it would be definitely a concern in terms of exponential growth if you just do the math, but it's not up there with some of the other viruses. That said, 20 million people infected worldwide, thousands upon thousands dead. There's more than enough nastiness in a baseline exponent of growth of 2.6 to do massive harm. So it's nasty enough, and the exponent's high enough to be a real problem.
And
obviously, as you respond to the with public health measures, your effective R changes quite dramatically. And intriguingly, when you look at literature, there's a group from Simon Fraser that's saying the R varies so much that they talked about an event R, where you try to figure out just what happens in some of these strange clustered situations, which again is why I I'm starting to think that the herd immunity levels may not be as high as one might think at first.
And just kind of why exactly is, compared to measles, does COVID-19 have a fairly low infection kind of rate?
Yeah, I think you would have to ask someone who has spent their life figuring out how exactly these different viruses evade the innate immune system and how exactly they have differential efficiency at hijacking cells for replication. And so the short answer is I don't know enough to give that a really informed answer, and I should probably just take a pass on trying to guess at it.
Sounds good. And we have one more question about international collaboration. And is the task force collaborating and or sharing data with equivalent bodies in other countries?
Yes, there's a lot of people on the task force who are connected to international groups, and so there's very frequent interchange. We've talked to the folks in the U.S. who are interested in serology and seroprevalence studies. We were compelled to do that. It's somewhat entertaining situation. We're working with a group of graduate students worldwide, all Canadians and expats in some cases, some here at home, who have mounted something called SeroTracker. You can find it on the web. It was written up in Lancet Infectious Disease about a week ago. And this thing is tracking all the seroprevalence studies worldwide and mapping them. And so it's a great exercise that helps put the whole world in perspective. And it turned out that the folks at NCI or the NIH were announcing their own SeroTracker, spelled the same, with the same capitalization of the T in the middle. So I thought, well, this is interesting. Imitation is the sincerest form of flattery, perhaps, but it turned out it was completely independent. So we had a great chat with them, and we're trying to figure out how to collaborate on these two mapping exercises and make sure that we find a way to harmonize rather than confuse. So that's been a good conversation. Typical of what goes on now, the turf wars are minimal. Everyone wants to talk and share. And it's a magic moment for science. The biggest worry is, to me, not so much collaboration, but we put a whole bunch of young people on ice because we've suspended some of our usual activities. Labs were closed for a long time. Young investigators who weren't in this field would be struggling to make their way. Some senior investigators and younger investigators pivoted and have capitalized on COVID funding. But, the response capacity we have in science in Canada was built over decades. And we can't have this event end up, being a situation where we don't continue building that capacity across the board. And to me, one of the big lessons of this terrible epidemic is Canada needs strong science capacity. It has to build the next generation. It has to sustain the current generation of scientists. It can't be focused only narrowly, because some of the people who are doing the best work pivoted from other areas. So that to me is the bigger long-term concern. Collaboration right now is brilliant, but let's make sure we build capacity at home to continue to do our fair share in the years ahead.
Okay, I think that's where we're going to wrap up. Thank you so much for joining us.
Okay. Always a pleasure. Thanks so much.
And thank you everyone for tuning in to our final live stream. We hope today's discussion was informative. I certainly learned a lot. We would love to hear what you thought about our entire COVID Decoded series. Our feedback survey is linked in the description. We'd also like to thank our Pillar Affinity sponsors, TD Insurance and MBNA. This series would not have been possible without their support. Check out the link in the description to learn more about preferred insurance rates and credit card rewards for U of T alumni. Also, if you missed any of our 7 previous live stream discussions, feel free to check them out here on our YouTube channel. Or we'll also be releasing the audio on our regular podcast platform on September 9th to kick off Season 5 of Raw Talk Podcast. We've covered a broad range of topics related to COVID-19, like virology, epidemiology and modeling, mental health, public health policy, testing, the intersection with the climate crisis, and equity. You can also follow us on Instagram, where we're sharing stories from frontline workers during the pandemic, within and beyond healthcare. Finally, support the show using our Amazon affiliate link in the video description. Thanks for tuning in, and until next time, keep it raw.